Unit 11, Day 1. Today is the first day of Unit 11, which is solids, and we're going to talk about prisms and cylinders, finding lateral area, surface area, and volume of both prisms and cylinders. Now, all the formulas we're going to use today are on your formula chart, which is here. If you scroll down, there's a section for surface area. There's one column for lateral, one column for total. So there's a different formula for each one of those. And then if you go and look further, you'll see the formulas for volume. But eventually we'll talk about all of these shapes, but today it's just the prism and the cylinder. So before we go any further, let's make sure we understand what the different terms mean when you're looking at the formula chart, as well as just what is each piece. Lateral area is the area around a figure, not including the bases. So for example, if I look at a room, which is a 3D figure, a room has 4 walls and a ceiling and a floor, right? So the lateral area would be the area of the 4 walls total, not including the top and bottom. So again, lateral area is the area around a figure. No basis. Total area is the area around a figure plus the basis. So if I'm using a room again, to find the total area, you would find the areas of all 4 walls and then add the area of the ceiling and the floor. So use that as a good analogy to help visualize what's going on so far. Volume is the amount of space within a room, or that fills up a shape or figure. So the amount of space inside a figure. So volume is like how much lotion is in a bottle, how much water is in your water bottle. That is the volume, that measurement. When you look at your formula chart and you see a capital P stands for the perimeter of the base figure. Now, perimeter of the base figure could be varying shapes. So, perimeter is usually just the add up all the sides. Capital B stands for the area of the base figure. So again, whatever the base figure is, you're going to find the area using the appropriate area formula for that figure. And it could be any shape it wants to be, or any polygon, should I say. When you see H stands for the three-dimensional height. when you see italicized L, that stands for the slant height. And R stands for the radius of the base, which would be a circle, because that's the only figure with a radius. So there are various types of solids. There are prisms, there are pyramids, there are cylinders, and there are cones. There are several types of prisms. A prism is a figure that has two parallel congruent bases, and their faces are rectangles. So on the one that's illustrated, this would be considered a triangular prism because the bases are these triangles here. And they're parallel to one another. So the base will determine the name of a prism, just FYI. In every prism, the faces are rectangles. So the sides, in other words, are rectangles. The bases would, think of the bases as the floor and the ceiling of your room. So the bases can be triangles, they can be squares, rectangles, so on and so forth. A cylinder has two parallel circular bases. So these would be the bases. So think of a soup can. The top of the can and the bottom of the can that you open are your bases. The curved surface connects the bases. So notice it's not an edge. It's just a curved surface. Then we have pyramids. Pyramids will have one base, and the one base can be any shape. And again, the base will determine the type of pyramid. So since this has a four-sided base, it looks to be a rectangle. So we would say it's a rectangular pyramid because the base is a rectangle. And if you notice, the difference between a prism and a pyramid is that the faces are triangles. And it's going to have a vertex, a point at the top. For prisms, again, the faces, the sides are rectangles. And lastly, you have the cone. The cone will have one circular base, which is this piece, and the curved surface connects the base to the vertex. So now we're going to practice naming solids real quick. This one is the same one from the previous slide. Since the bases, which are these parallel parts, are triangles, this is a triangular prism. On this one, the bases are these hexagons. So it's a hexagonal prism. This one was also on the previous slide. It's a rectangular pyramid. Pyramid because the sides are triangles. This has, you can say this is the base, and the base would be down here as well. So you could say it's a square prism, or it's commonly known as a cube, since the bases are squares, because the tallies indicate that those four sides are congruent. And this last figure would be a triangular prism because the one base is a triangle and all the faces, all the sides of the figure are triangles. So it's a triangular pyramid. I said that the first time right. I hope I did. So now, again, we'll practice finding the lateral surface area and volume of a prism and a cylinder. The bases will be highlighted throughout these examples to help us out, especially with with rectangular prisms, because there's two sets of parallel sides. Actually, three sets of parallel sides. Sorry. So the yellow ones are your bases, and they're not all four sides aren't the same. So this is a rectangular. I spelled that all wrong. Prism. So P again stands for the perimeter of the base. So to find the perimeter of the base, since it is a rectangle, it's 2 times length plus 2 times width, which should be on your formula chart. So that would be 2 times 13 plus 2 times 2.5, which equals 31. My lord. I'm sure you could have figured that out much faster in your head. That calculator is moving slow. So the perimeter is 31. Capital B, again, stands for the area of the base. So again, it is a rectangle. So area is length times width. So that would be 13 times 2.5. $32.5. H stands for the 3D height. In this picture, the 3D height is 18. And don't forget your units. Perimeter is inches. Area for the base is inches squared. And height is simply inches. Now, if I go to my formula chart, the lateral area for a prism is perimeter times height. And the total area is perimeter times height plus 2 times b. So let's go ahead and write those formulas down while we're thinking of them. So lateral area is perimeter times height. Total is perimeter times height plus 2 times b. So perimeter times height, that's 31 times 18. Which is 558 inches squared. Area is always squared. Now, if you notice the total area, you need perimeter times height, which we just found, is 558. And then you're going to add 2 times b. So that's 2 times 32.5. So let's grab the calculator again. So 58 or 558 plus 2 times 32.5. 623. 623 inches squared. Again, it's area, so it's squared. Now we need the formula for volume. Back to the chart. The formula for volume for a prism says it is B times H. B times H. So area of the base times the height. So the area of the base was 32.5 inches squared times the height, which is 18 inches. So that would give us 32.5 times 18. 585. 585 inches cubed. Volume is three dimensions, so it must be raised to the third power, your units. Please put your units on all of your answers and the correct unit placement. So again, perimeter is inches. Anything that's one dimension is inches, or it's singular. Area requires two things to be multiplied, so it's squared always, and volume is always cubed. All right. This is a triangular prism. Because the parallel bases are triangles. So the first thing you're going to have to do is find the height of the base, because we're going to need that height to find the area of the base for big B later. So we use Pythagorean's theorem, and we have A and C. So H is going to equal, or let's call it B. B is going to equal 13 squared minus 12 squared. And this one we've seen a lot, so it should be 5. So this is 5. That's the height of the triangle base. That is not the height of that's not the 3D height. The 3D height, since I'm speaking about it, is 20 inches. It's that side piece here. It connects your bases. In other words, 3D height will connect your bases on a prism. All right, so let's find the perimeter of the base. Since it's a triangle, we're going to add all three sides. So that's 5 plus 12 plus 13, 25, 30. So 30 inches is the perimeter of the base. Big B stands for the area of the base, and the base again is a triangle, so that would be base times height divided by 2. So that's 12 times 5 divided by 2. 12 times 5 is 60, so that's also 30 inches, but squared. And we've already established that the height, the 3D height, is 20 inches. Now the lateral area for it's still a prism, so it's going to be perimeter times height. So that's 30 times 20, which would equal 600 inches squared. Total area, again, is perimeter times height plus the two bases. So that means it's 600 plus 2 times 30. 2 times 30 is 60, so that's 660 inches squared. Volume, again, is B times H, which is 30 times 20, which is again 600, but this time it's inches cubed. So that's how you would use the formulas if it was a triangular prism. Now let's manipulate some cylinders. Again, P is for perimeter, but if perimeter of your base, and since it's a cylinder, the base is circular, so perimeter is technically the circumference of the circle, which has the formula 2 times pi times radius. So that's 2 times pi times 4. And that would give us 8 pi. But it's okay to convert it to decimal because pi is going to do that. And I already have decimals in my answer. So 8 times pi is approximately 25.1 centimeters. B again stands for the area of the base, and the area is pi times radius squared. So that's pi times 4 squared, so 16 pi, which calculates to be 50.3 centimeters squared. And then the 3D height is 13.8 centimeters. Now let's consult our formula chart for the formulas for lateral area, total area, and volume. So for a cylinder, the lateral area is 2 times pi times radius times height. The total will be that first piece plus the two bases. Okay. And then for volume, it's BH, just like it was for the prism. All right, let's write this down before we forget. So for lateral area, it was 2 times pi times radius times h. For total, it was 2 times pi times radius times h plus 2 times pi times radius squared. And For the volume, it was B times H. And let me just double check that I did all of that correctly. Yes, I did. Good. Alrighty. So that's 2 pi times 4 times 13.8, which would give us 2 times pi times 4 times 13.8. Approximately 346.8 centimeters squared. Okay. I need the first part again, so 346.8, and then plus 2 times pi times 4 squared. So this plus 2 times pi times 4 squared. So 447.4. 447.4 centimeters squared again. Now for volume, I take my 50.3, multiply it with my 13.8. You get 694.1 roughly. 694.1 centimeters cubed. Work on this one on your own, and this concludes your notes for today. I apologize for it being so long.